Okay. So we'll go ahead and get started. The individual just told me he's joining right now. So, um, first of all, welcome to this webinar series, Large Language Models. We are super excited to launch this series. We have two um, very, I would say, astute individuals who have a very strong background in AI and learning, machine learning. Um, I'm going to be introducing them both here in a few minutes, but I want to introduce myself to everyone as well. Some of you may be aware of who we are, Arthur Lawrence. We are IT professional services firm, and we work very closely with a lot of Fortune organizations, small, medium, and large, to provide top-tier talent. So, um, without further ado, I'm the managing partner of the talent practice, and we have formed a really strategic partnership with the two individuals on this who are going to be presenting on this webinar. Rudy Agovic. Rudy is recognized as an expert in AI and machine learning. He has a successful track record of helping organizations digitally transform and adopt new technology. One of his key expertise is really guiding on data strategy, augmenting business processes with AI, and implementing simulations and digital twins. Rudy holds a PhD from the University of Minnesota and in machine learning. He was also named in 2021 key opinion leader by Analytica. Um, Also, we have Amir Agonovic. Amir is a experienced NLP expert and architect, and with who architects end-to-end systems. He also has a PhD in robotics from the University of Minnesota. Um, he is he has extensive expertise in signal processing, embedded systems, and deploying IoT solutions. Amir has led some of the most impactful efforts in applying NLP and computer vision to automating a lot of Fortune 500 clients. Armor 2 has been published in top tier conferences in computer vision and robotics. So we are very pleased to have both individuals on this webinar series and sharing their knowledge and sharing some insight. Without further ado, I'm it off to Rudy, who will take it from here. And we look forward to some insightful conversation here.
All right. Well, thank you, Vijay. We are also really looking forward to this webinar series and also to our partnership. Now I'm going to turn on my slides over here, my screen sharing, and let's just get going in the interest of time. Okay, let me know if you're able to see my screen. Vijay?
Now I can see your screen, yes.
We can see your screen. We're good.
All right. So let me maximize here the most I can. All right. So yeah, a lot has been happening. First of all, before I get started, I've noticed that I'm not able to respond to comments on LinkedIn. So if you leave a comment, I will probably respond to it later after the webinar. Also, I have done, or we have rather done, a number of these webinars. And usually what you can expect after the webinar, whether you attended live or not, is we try to reach out and send you a recording to the webinar. Typically, I also prepare like a set of references that allow you to take a deeper dive into these topics. So there'll be the slides from this presentation and then also those references. If we're not able to get a hold of you at the end of this presentation, there's an email for this webinar specifically, where you can reach out and get a hold of us so that we can send it to you. This is being done through Microsoft Teams and streamed live on LinkedIn right now. So let's dive in. A lot has been happening in the world of generative AI over the last couple of weeks. And the field generally is extremely quick, moving fast. It can be difficult to keep track of what's, of all the recent developments of what's going on, and especially with some of the drama that has been happening lately. So we thought it would be a good idea to organize this webinar to kind of, provide people a perspective of where the field has moved, what exactly does that mean for businesses, and what we can expect further down the road. So this talk is organized as follows. First, we will go through an overview of large language models. Now, what we're looking to do with this overview is really give you a sense of what large language models are, but also identify limitations, capabilities, and what constitutes easy versus hard use cases. And so then in the context of that, we will then dive into more recent developments. We will cover some of the announcements that came out of OpenAI and Amazon. We will talk about the fusion of large language models and planning. And then we'll talk about the fusion of large language models and information retrieval. After that, we'll go into small language models, agents, large context windows, and a deployment framework called LoRags. So these are all, well, they might seem like they're not connected to each other, but these are all kind of recent advancements that we thought were worthwhile to share with you. So that's kind of where this is all coming from, and also it's trying to contrast what OpenAI recently put out with what's available out there in open source and frameworks that are not proprietary. So yeah, and I will be covering about the first half of this presentation, and then I will shift over to Amr, and then he'll continue on the second piece. So with that being said, let's get going. So first off, let's talk about large language models. And here, I do first want to give you kind of a sense of what they are, and a sense that's not necessarily very theoretical, or it doesn't go into the details. We have a large audience here with a nice mix of technical people and not so technical people. So I've tried to keep this somewhere in the middle to provide a balance. So what are large language models? Well, if you listen to people out there, you're going to encounter folks that will say this is a first step towards artificial general intelligence. It's amazing. It's going to change the world. It's already changing the world. The world is going to end. So those are some of the things you might hear. On the other spectrum of things, you might hear that, well, these models are really just capturing statistical correlations in text. There isn't really a whole lot happening. So to kind of get a better sense for, like what the model actually is, I have here an example of a sentence where it says, "Where is Waldo?" So the way this model is formulated is really just to predict in a sequence of words. So if given a sentence, this particular model will predict the next word. So that's all it does. And so you may wonder, well, so what is all this hype about? Like, how is a model like this that just predicts the next word, worthy of all of this, and how is it generating the value that it is? Like a lot of people have been exposed to ChatGPT, and most people already know kind of, like the level of, the level of sophistication that these models have when it comes to having a human-sounding conversation. So the models are built in something called a transformer architecture that has very, very many parameters. billions. There's even some models that have like 1 trillion. These parameters are not just used to store the ability to have human-sounding conversation. They're used to store facts, relationships, and those kinds of things. And the other thing you might hear about these models is that they're autoregressive. What autoregressive means is when you have a sentence like this, if you want to generate the next word, this, where is Waldo sentence becomes your input for the next word. The models have, like these large language models, they've been trained on enormous amounts of data that, they include code, Wikipedia, web, public books, even proprietary data. And so there's some, like there's even some contention about that, whether the data that was used to train them is, is something that, is okay to use because of copyright issues. So what I would say here is, there is an interview that Ilya, I have a hard time pronouncing his last name, the chief scientist at OpenAI, that was involved in the ousting of Sam Altman. There's an interview with him and the CEO of NVIDIA, and that was recorded just after GPT-4 came out. You can Google it on YouTube. I would strongly suggest to watch it. What's interesting about that interview is that he gives some insight about how OpenAI folks are viewing this and where the motivations come from. In particular, one of the things that they observed early on is if they looked at models that just predict the next character rather than the next word, they were capturing interesting aspects along the way, like they would be able to capture sentiment. And this type of work motivated, going to a word level. And the way they view this model is as doing compression. So you can think of it as, you take all this data that's available in the world, and now this model is trying to learn how to compress all this knowledge and all the data out there. And their argument here is that in order to really effectively compress, the knowledge of the world or the data of the world, you have to, along the way, somehow build a model of the world to understand how to compress data effectively. And so that's the way they're viewing this model, these types of models. They're not just so that there was this realization that even though the model is created for this much simpler task, which is to predict the next word, it's actually capturing a whole lot more along the way. And the way they think about it is as a compression model. And so then if you use the model and fine tune it on very specific tasks, like I don't know, coding would be one example, then you're basically teaching it how to compress that, and in the process of that, it needs, it has to figure out coding to some degree. And so that's the viewpoint, that when you listen to some folks like Hinton, and this chief scientist from OpenAI is a student of his, they'll say things like this, that like this model is actually capturing a model of the world, and then the question is how much expressiveness does this model have? How much is it capable to do? And that's how they justify the capabilities that came with ChatGPT. Now, what was interesting is a lot of these capabilities, they kind of emerged once a larger scale was explored. So it was not necessarily evident when they tried out smaller models, but once they went beyond a certain scale, then these models started to basically gain capabilities like a certain level of reasoning. They were able to solve problems that they were not able to solve before. And so, I thought that was a very, the best kind of explanation that I have come across as far as, like why they think that this captures a model of the world as kind of a side effect. But the problem formulation at hand is really just predict the next word. And it's really amazing that all of these capabilities come out of that. And like the truth of it is, this isn't like something that even the people in the field know exactly, like what are the capabilities of this model, where do they end. I mean, based on experiments and sort of empirical evidence, people are kind of trying to gauge that. So that's just kind of a view of large language models that's a bit different. Again, I highly recommend that interview. Moving on. So, like when people discuss large language models, some of them are really excited about it and businesses want to implement it, but then a number of businesses kind of step back and are looking at where is this killer application? Is this really just a whole bunch of hype? Is there actual value to back this up, and a justification to actually invest all this money into it? And so really the bottom line of it is, the models as they are currently, a lot of people talk to them about what they could be at some point in time. They try out ChatGPT. It's great for certain things, but for it to be usable in a business, it needs to be reliable, and that it is not yet. Not across the board. So these models, as you all know, they make mistakes, and so like the question is, if we look at large language models in the state that they're right now, how usable are they for businesses? Let's take, get rid of all the hype and all the, expectations of what this could become eventually. And so I think that's one big part of the frustration that, depending on, well, first of all, you have to understand the capabilities and limitations of these models. But then depending on what use case they're looking at, they might be really useful right now, or they might be really difficult to work with. And so what I tried to do here is provide a sense of that. And this is kind of an arbitrary categorization just to illustrate the point that there's a spectrum of difficulty. And so so what would constitute a low-hanging fruit with large language models if I'm a business? So I've tried to identify certain factors, and like for example, tasks that rely on generic knowledge, which would already be in the large language model, tasks where I do not need to infuse my own business data into it, and tasks where some errors are acceptable. So for instance, as an example, I might build a large language models where I give it emails and I ask it to interpret the emails to tell me whether there is people trying to sell me things there. Are these marketing emails? Basically help me interpret and categorize emails. This would be an example of a low-hanging fruit because I can fully leverage the capabilities of the model. And even if it makes a mistake here or there, it's probably not going to be as bad as my spam filter, which is killing me. So that will be an example of low-hanging fruit. So then what would constitute a slightly harder use case? Well, I call this a high-hanging fruit. That would be an example of where now I want to use it for my business, and I want this model to somehow interface or interact with my business data. Now, a use case that would be slightly harder but still very much achievable would be where my data is compartmentalized and it is easily retrieved. So let's say I have a use case where I'm in a call center and there's the people are calling in, and the model is supposed to aid the call center employees to retrieve relevant information. And if, let's say, I'm asking, like, let's say this call center is for providing support for a, I don't know, appliance. Then presumably I will have documents where, I have user manuals for the appliance, where I have my data is already organized in sections that are coherent in terms of what is being discussed. That's what I mean with it being compartmentalized. And I can then, like if it's a matter of just honing in on that piece of text. If I have a use case like that, then that would be something that is very much attainable. It's slightly more work than this low-hanging fruit, but like that just the fact that you have to interface with your own data makes it a bit more challenging, but that would be the high-hanging fruit. And then I have here one that I say that I call mountain climb. Here, now in a lot of businesses, you may have text, but the reality of it is you also have databases, structured data that's in tables, that's might be in some kind of a well other kind of structure, where like you now need to go out and you need to collect this data. So if I have a question, let's say we have the same example of I have a person that's calling in a call center, but now the information about my I'm talking like refrigerator or whatnot, this information is no longer in one place, it's in multiple places. I have to now work harder. And if I have also a requirement along the way that hallucinations are not acceptable, that makes it also a harder problem. Now, one thing that makes it a bit easier is if I narrow the task and I say, okay, this is going to be a model specifically for providing support for refrigerators. That narrows down the task. It's not, allowing the user to talk about anything under the roof or anything that they could think of, but it's very targeted. And so then I have this last one that I call a moon mission. Maybe that's a bit, over the top. Maybe it's not as hard as a moon mission, but where it becomes really difficult or much more difficult is if your business is in a specialized domain and the ability to retrieve relevant data to answer questions is complicated. It's not just here it is. It's, oh, I need to somehow piece together data from multiple places. And then I need to somehow apply logic. I might have to do reasoning. I might have to do domain-specific reasoning. And then on top of that, if the errors are not acceptable, and if the task is broad, that makes it difficult. So task is broad. What would that mean? Well, let's say you have an agent, you want to create a chatbot, and you want to allow your customer to just ask away anything about your business and whatnot. That would make it broad, and that makes it more difficult. So this is a one possible categorization of the spectrum, just to give a sense for what you would constitute a simple implementation and what would mean a whole lot more work. So implementing something that's under this moon mission is actually a lot more representative of what business data looks like, and where the low-hanging fruit might be a matter of a month to get, or a month or 2 to 3 months to get something out. The moon mission might take you a year. So that's kind of the distinction. So before we dive into specifically what was introduced or done and developed, I thought that this was really important because if we're talking about things that recent developments, it's kind of important to try to understand what problem are these developments addressing, so that whether that development is actually valuable and important, or whether it's just something that's kind of convenient. So that's why we're going through all of this. So the key factors here that we've kind of identified in whether the problem is hard or easy, it would be, is external data needed? How hard is it to retrieve answers? Is domain knowledge needed? Is complex reasoning needed? Are errors permitted? And this question of are errors permitted, you can also think of it in a different way. You can think of it as, do we use the model to make decisions for us? Or do we use the model in an assistive manner? So if the model is an assistant to me, then you have a human in the loop, you have somebody that makes the final decisions, and then errors are permitted, more acceptable in that setting. So that becomes, if you think about Microsoft Copilot and a lot of the creative use cases, wherever these models are used as an assistant, then living with hallucinations and errors makes it a bit easier. Now, and then lastly, a question of whether the use case is task specific or broad. Now, So that's a categorization of the various use cases. I also want to touch upon briefly capabilities and limitations of these models. So we talked about this being a compression model that is along the way capturing some model of the world as kind of the OpenAI folks see it. But after all this time that has been out, and there's also open source models, what kinds of conclusions can we kind of make? One is that it's really capable in having a human sounding conversation. You could almost say that there's another human on the other side. And as a matter of fact, there was a former Google employee that thought that their internal model was sentient. So that's where they're really good. When it comes to factual accuracy, that's these models are really interesting in that they are able to get so much data internalized. It's like you have the knowledge of the world is at your fingertips. But the problem along with that is that it's not perfect in that sense, in that if it doesn't know something, it might make things up. And that can be a problem for business applications. So factual accuracy, I'd say it's somewhat capable. It's impressive on one side how much the vast knowledge it captures, but at the same time, it has a reliability problem. Now, there are two other areas here. One is reasoning. Now, reasoning, if you talk to it, you could say, well, it's doing some level of reasoning, but there's a lot of research that has gone into this and how to improve the reasoning, and kind of the where things are is that a realization that these models have some capabilities when it comes to reasoning, but there are two things that they can do very well. One is abstract reasoning. So if we're doing math or we need to kind of have a meta view of things, then they don't do so well. And they also don't do very well on problems that have not been seen like that in their training data. So if I have something that's really similar, and then there's very weird things that you'll come across, like if in your training data you have a statement that says A is B, the model will not know that B is A, or that also B is A. So it's not really great at these types of reasoning tasks. And then the last one is planning. Planning and reasoning are kind of related, but it's really important. The planning part is if I have a complicated problem and I need to divide it into more manageable subproblems, it's not good at doing that. So those are the limitations. And so as we're looking at developments, so it's kind of interesting to see which of these they're trying to improve. And then along with the capabilities and limitations, there's other implementation challenges that come along with the large language models. One would be cost. One would be skills. Like it's hard to get the talent. Not everybody has access. Privacy, is my data going to be safe? Somebody, is it going to show up on somebody else's account in their conversations? And then bias. Bias, whether the data is skewed or not. Now, you may think about bias as this, like, okay, you have some weights and you have more of one class than the other. What's the big deal? Oh, it's a big deal. And I'll tell you why it's a big deal. Let's say, as it is the case right now, with, let's say, algorithms that make decisions who will be shown to a hiring manager, who will be hired. If your algorithm, because if it's biased, is preferring certain group of people, you're already, you're basically deploying discrimination, and it's having, a real life impact on people. So this issue of bias is an important one. So these would be the challenges. I've gone on quite a bit now on all this background, so bear with me. I hope that it's all going to make a lot more sense as we dive into this now. So what I want to do next is cover some of the things that came out of OpenAI. So as we know, the CEO was ousted, and there's a lot of drama around that. I don't want to get into that. Just before that drama, they had an event, like a conference for developers, Dev Day, where they announced a number of new things, and I just want to briefly touch upon these. So a couple of things. There's a new version of GPT-4, something they call GPTs, and an API for assistant assistant, that should be rather than assistants, assistant API beta version. So those three I'll dive in a bit deeper in a moment. And then they have custom models, which is basically the ability for businesses to engage OpenAI in kind of a consulting agreement. This is mostly for businesses that can afford it. So it would be expensive, but the idea is that they'll have a team of people that will help companies implement models on their domain data. And the last one here that I found noteworthy is what they call a copyright shield, which is basically they're saying is if somebody sues you for infringing on copyrights, let's say you are quoting things from a book that you should not be quoting, then OpenAI will basically protect you legally against those kinds of lawsuits. So that's like an assurance. But the question is, the reality of it is this all sounds great, but after what happened recently, where businesses really are is they're asking themselves, should we really even trust OpenAI? And then we're talking like, in some cases, millions of investment. So, like, well, what makes sense here to do? So these are some of the things that they announced. I'll just briefly go through them and kind of to contrast this with the limitations of the models and see how much, like when this came out first, you could see things on LinkedIn like, oh, this is groundbreaking. It's like a shift, like this is going to change everything. So let's see how much this is going to change. That's really the point here. So what they did here is they put out a new model that is supposed to be more capable than GPT-4, has a window size of 128,000. That means you can have whole book you can give it and you can ask questions. The window size refers to how much text you can give to the model. It has some abilities to format the data that's more important to like developers. And then the knowledge cutoff was changed to be more recent, and they've promised to keep this more recent. So it used to be 2021 and you couldn't ask any more recent questions, whereas some of the competitor models like Claude, you could do that. So they've changed that. They have incorporated the ability to reproduce output. If you are a data scientist or computer scientist, all that it means is that you have the ability to fix the random seed, so you can always get the same response. And it's really more something that's important for testing purposes. Now, one thing that is important to businesses is they've reduced the price for various of their models, and they have two versions of this model. One is text only, and one is a model that incorporates both vision and text. That means you can give it an image and you can ask questions about that image, which opens up the door for a whole variety of new types of applications. So that's one. So we've kind of an upgrade for the existing model. The next piece that they introduce is what they call GPTs. So what this is they have basically providing a no-code capability where you go in, and I can switch over here. This is kind of what that looks like. There's a little button in the corner that allows you to get to this. And what this is a no-code ability to create your own GPT version. To say, okay, I want you to be my assistant for Python coding. I want you to do ABC. And then without having any programming skills to be able to deploy this new agent, and they're working on having basically a store, an app store, where you can then deploy these agents that you just built. So this is actually pretty interesting. It's interesting because it makes things more accessible. You can program it by speaking to it. And the other reason why this is interesting is they've incorporated in here something called actions, or custom actions rather. And through those custom actions, you have the ability to expose external resources or external data sources. So if you come back to this example, of email filtering, I get 200 emails a day, and I'm swamped, and my spam filters don't work. So presumably I could go in here and say something like, okay, let's create a GPT for me that will take my emails and categorize them into these categories that I care about. Like these are from the salespeople, these are, my team members. And here's, by the way, the custom action that will allow you to get the emails. And here is the custom action that will allow you to, let's say, send the notifications to me or store results, or in a database. So this it opens up. I think it's really valuable from a sense of providing automation capabilities. Another way that I have already seen people use this is to create kind of like a little helper agent. So, for example, let's say you want to create an agent that gives you, like advice around how to get the best deals on Black Friday. Okay, so maybe you take a document that has a bunch of instructions, about what you should be doing, and you have the ability here to upload that document and let this agent use that as instructions, and then you tell it, okay, this is what I want you to do. And so now you have an agent that basically provides advice around what to do on Black Friday, and you've done it without doing any programming. So from a productivity standpoint, this is pretty neat. And keep in mind also that when you talk about Microsoft ecosystem, Microsoft has a framework called Power Automate that allows you to basically add automation steps. So I can foresee is this, this as being something, if it ends up being integrated there, as being really impactful and useful. So that's the second one, which I thought was really interesting. And then the last one is this assistance API, which isn't, no code. It's really more for people that want to create what they call agent-like experiences. You can think of an agent as kind of a autonomous program that makes decisions, and this agent uses tools to interact with the environment or uses language. And they have added some capabilities here, like managed conversation sessions. So if you're programming that, it allows you sort of to do some of this management. If you've implemented large language models, you know what that is. But what's really kind of interesting here is the ability to invoke what they call a code interpreter, which is these agents can execute Python code. So it's kind of like having your analyst assistant there, but you can tell it, oh, can you tell me what the trend is for, like what was the weather like, or what it will be like, and like some kind of computations that can be done in Python and then visualized to you. But the other part piece here is sort of also mentioned along the way is knowledge retrieval. And that's kind of a big one. It is the ability to take your business data and have it be processed in a way so that it's stored and that it could be infused into the context. We'll talk about this a little bit more later on, but this is something that has scared a lot of startups, and we'll mention why. So that's kind of overview of what they released, and putting this in the context of what we discussed earlier on about limitations and capabilities. This is, addresses the fact that, you get cheaper access to their system. It's more capable. It's more accessible in the sense that you can do things without having to do programming, and you have this retrieval capability. What they have not done here with, like these groundbreaking changes is address the reasoning limitations, planning limitations, and the inherent hallucinations that come with these models. And so if you think about, well, what is it that makes the models not so reliable for me? Those reliability issues, they have not really been addressed in this iteration. So that's OpenAI. Just a quick note on Amazon. This, like we don't have a whole lot of time, so I'll have to kind of speed things up. Only yesterday they announced this. So they put out a competitor agent to ChatGPT, which is called Amazon Q, and it is focused on business use cases. So it can do things like help people create content, do search within the business, summarize things, and get insights. And what they're claiming is that it's accurate, that it will provide citations with its responses, and that it allows you to have access controls of who can see what and have guardrails. But then they also say it's able to connect with about 40 different popular enterprise applications. So this, if these claims are true, would be significant, because if you looked at the use cases they kind of gone through, having the ability to look at across different business domains is not that trivial. And so claiming that they can do that accurately is something that I would like to see. So for me, it's kind of questionable that I have addressed these sort of inherent problems, which come down to reasoning, planning, and hallucinations. And I'd like to see these claims be proven in practice. So next one we want to quickly address is this fusion of planning and large language models. Now, a disclaimer here. This fusion is something that doesn't exist yet. And this is something that a lot of people think will make large language models or these types of models more reliable for business. And also, this is why a lot of people are afraid that we may have kind of a first version of a more general artificial intelligence. So what is this? So I will not, again, spend a whole lot of time because we have a lot of content to cover. But let's just look at Google DeepMind and OpenAI specifically. These companies are both involved in competing in various games. Apologies. They were both involved in competing in various games using something called deep reinforcement learning. I don't know how many of you remember, DeepMind came with a model to compete in the game of Go. And this is a board game that's very complicated. It requires strategy, creativity, ingenuity. And what they did is in 2016, they built a model, reinforcement learning model, that was able to beat the current champion at that time. And so that was great. Now, what they did in 2017 was even more interesting. There, they let this, so they built one of these reinforcement learning agents, and the agent trained itself how to play this game with no human interaction, and then beat the best, like the best human out there, the champion. So, think about this. If everybody's talking about AGI, about all these capabilities, like this system was trained with no intervention, and it at the end of the day did more consistently and better than the best human out there. And imagine if something like this was possible for other tasks. Let's say I want that call center assistant. I want to train a model that, well, first of all, a model that will teach itself how to be better than any human out there. So you can see how this, if it were possible, would be kind of a step in general artificial intelligence. And the particular method here is called deep reinforcement learning alongside with the tree search. Now, it turns out it's one thing to do this for a specific domain like Go, but it's a whole other thing to make this possible across a more generic setting. Google has announced that they're working on a model called Gemini, and the release of that model has been delayed to next year. And the claim there is that they're going to take some of the capabilities of AlphaGo and merge them with a large language model to address some of the reasoning and planning shortcomings that large language models have. Maybe it would not be as, in this example, that it just beats every human, but at least get it to a point where the large language models or these systems are more reliable and with that more useful for businesses. So this is something like, this isn't like some secretive thing, or that well, that based on rumors. These are actual announcements from this company. So that's ongoing research. Now, OpenAI, Ilya, the chief scientist, came from DeepMind. He was hired away. They also were involved in using deep reinforcement learning to play games. In 2019, they played a game called Dota 2, which is like a video game. It's not a board game. It's also a complicated game where a computer before was not able to do, beat humans. And they built a reinforcement learning system that was able to beat the, win a competition basically. So they also have this sort of exposure and experience to this type of deep reinforcement learning. And they also have, if you look at the work that they've done, they have work on self-learning kind of agents, or self-play techniques, they call them, where you have, basically one of these agents that plays against itself and learns that way. And then in March 2023, there's a paper from them on improving mathematical reasoning with process supervision, which is basically, rather than looking at the outcome alone when you're looking at reasoning, to look at how you arrived at that outcome and internalize that in the model. So the reason I'm mentioning all of this is there's been talk about this model called Q star that is, apparently was the reason for firing the CEO, and that a lot of people are afraid of. The reality of it is likely, I don't know the exact nature of it, is that it is work that's along similar lines of what DeepMind is trying to do. So idea would be to use deep reinforcement learning and fuse that with large language models. And the reasoning comes into play here because you're looking at the steps in the reasoning process. That's what you're planning out. So you're helping with planning and with reasoning. So that's kind of the idea. And there's also a recent comment from Jan LeCun that Meta is also working on this problem. So we got all these three major companies are trying to address these two shortcomings that are well aware of: planning and reasoning. And given the amount of effort that's going into that, you can expect there's going to be improvements in that direction. Meaning, if you're a business and you're not happy with the state of large language models now, you can expect that they will become better. This is all sort of in the future. It's not the now. And one thing that it's not quite clear here is whether these kinds of adaptations will take care of the hallucinations problem. But again, these are things that are not even released yet, so we'll worry about them when they come out. But I did want to mention this because Q star was mentioned, and it is a big sort of limitation of these models that a lot of people out there are trying to address. Now, let's dive into the fusion of information retrieval and large language models. The reason I want to dive into this is because, again, it became very, very current and relevant because OpenAI just incorporated knowledge retrieval into their system. So it is possible now to take your data, get it internalized in OpenAI, and then as you are asking questions, get that data into the context. So that's really what this marriage between information retrieval and LLMs is. It's called retrieval augmented generation. And the idea here is if a person asks a question, and first of all, the problem you're trying to address here is how do I incorporate business knowledge into the model? How do I let my customer talk to a large language model where it's talking about my business data? And so this would be one way to do it. And what this basically is doing is saying, okay, I will take the question of the customer, I will do some kind of a really smart search and retrieve all the relevant documents for that question. So if I ask them about a refrigerator, I'm going to get all the documents on the refrigerator. And then I take those documents and I serve them to the large language model and say, okay, now tell me, how do I replace the filter? And large language model will just then look at those documents and generate the answer. So that's the idea. Now, the reality of this is that there is off-the-shelf products now. And the way this retrieval augmented generation is implemented is usually utilizing something called vector databases. So how does that work? Well, the way that works is you take your data and first of all, you somehow, this is really semantic type of search that is sort of the traditional search. So you have a request, the request is encoded into a numeric representation, and then you take your business data and you encode that into a numeric representation. And the way you do that is first you do something what's called chunking. So you take your documents and you organize them into coherent pieces. So part that talks about refrigerator, part about talks about I don't know, the stove, so that then, like when I encode this data, that what I'm encoding is always sort of from a topic standpoint is sort of coherent. And so that's the what you do with this chunking. And once you do that, it gets encoded and stored in a vector database. And so basically what OpenAI is saying is they're providing this capability as well. And there has been a whole array of startups that were created to do the same thing. And this actual diagram here is from one of those startups called Vectara. So what happens then? So if you have done this to your data, you basically, you have a bunch of vectors that are stored, you have a query, and then you do what's called a dot product, or it's kind of, well, I don't want to get too mathematical, but it's cosine similarity really between two vectors that will then retrieve the most relevant chunks of information. You then take those chunks and use them as a context in your large language model. So that's the basic idea. And given that OpenAI has just incorporated them themselves, they must be seeing this as a very legitimate way to go about this. So and then you have the startups that are worrying, now that OpenAI has adopted this, does that mean the startups are basically gone and done with? The challenge here is, so this approach does not really, well, first of all, let's say that people that have tried this, they have very mixed results. And the mixed results are primarily driven by how their data is internally organized. So frequently, it is not so easy to chunk the data. So when you're saying, I'm going to transform this problem, or I take the question to the user and I turn it into a search problem, well, then you're basically taking all that's difficult about this interaction, and you're making it into a search problem. So you better be able to easily retrieve that data, but in practice the data is scattered, both structured and unstructured data. You might even need domain knowledge to retrieve what's relevant to you, or you might have to do multiple searches to get to the answer. So that's kind of all things that make this sort of setting of a vector database only narrowly applicable. It's not that it's useless. So the reason why this is helpful and useful is that you have an off-the-shelf product. And if you implement this, you don't have to fine-tune the model. So it's an inexpensive way to get something going. But in order to be able to leverage this type of approach, your data needs to be a good fit for it. And if it isn't, then like you could either ask yourself, how do I adapt this to my more complicated data? So you realize then that, okay, my search is a mess. In my case, I need to go out and I figure out, how do I gather all of this information? What databases do I need to go to? And so you can do that. So that's not what I want to say, is that this isn't a problem of retrieval augmented generation. The conceptual idea still works. You can have here more sophisticated search. You could be looking at a knowledge graph. You can be looking at other kinds of things. But the off-the-shelf products, they're only useful when the data is organized in a specific way that's easy to retrieve. So if you keep that in mind, then like I have, coming back here to examples to illustrate where this is useful and where it's not useful. I already gave an example of this call center previously, where if you have your data that's kind of compartmentalized and organized by topic already, ultimately, it's easy to get to that information, and the large language model doesn't have to do a whole lot, just kind of summarize the response. But there is, consider a use case that, let's say you built a bot for home insurance for a client to ask questions about the policy. Well, here things get more complicated. Now, the data might be in the policy document, but it might also be in some kind of a database that keeps the contract terms. When you're asking about, is this, so let's say I just had some damage on my house, is it covered? The answer to that question will likely not be just one paragraph. It will probably be in some, a number of clauses that are, spilled throughout that document. So your search needs to be able to fuse together all those clauses that are relevant. And then at the end of the day, when you give the summary to the large language model, it will not maybe be readily available. You may still have to interpret, is this covered or not? So there may be a factor where you have to do reasoning. And this becomes a much more difficult use case. I suggest take a look at a blog from a company called Zelros, where they actually covered this use case. And you'll see they ended up adopting a more sophisticated version of retrieval augmented generation. But yeah, advantages are it's an easy way to get going if your data is organized the right way. And if no domain knowledge is required for the large language model to interpret the data. Now, if domain knowledge is necessary, what that means is, think of it like this. I might be, I might get instructions on how to, let's say, fix an airplane. Somebody might serve that to me, but if I don't know how to fix airplanes, even though the information is right in front of me, it's not going to be very useful to me. So the same thing with the large language models. If domain knowledge is necessary to accomplish the task, then then it's a more complicated endeavor. It's not that it's not possible; it's just more involved. I will only briefly mention this because we're kind of tight with time. So as far as more recent work goes, within this space of retrieval augmented generation, there is an approach called self-RAG. What that is basically the attempt to build a model that will learn when to ask the outside source for information. And then also it will try to learn the relevance of that information from the outside source. And so this kind of is trying to teach itself. And here, the search problem is not completely detached from the large language model, which is kind of interesting. So I would suggest take a look at this if this is something of interest to you. At this point, I've already taken up a whole lot of time, but we started a bit late, so I'm going to move over. Let Amr take over from here.
Hi guys, we don't have a lot of time, so I'll be brief. So if Rudy's part of the talk was about shooting for the stars, this second part is about squeezing the most you can out of what's available. And the first thing is about these small language models. They're all large language models. You can maybe better would be to call them minified LLMs, right? But it's basically trying to compress what ChatGPT-3 with 130 billion parameters does into maybe something that will fit into 7 or 13 billion parameters. So that's what these small language models do. Of special note is this Mistral 7B, because they applied some tricks to improve attention, and that helped them achieve better results. The next slide, Rudy, talks about. You can move to the next slide. It talks about Zephyr 7B. Zephyr and the next one, Orca, are two examples of these minified or small language models. Zephyr is a specialization towards better discourse. The next one, Rudy, Orca, is coming from Microsoft and is a specialization going towards reasoning. So you can see that it's about smaller models that can fit into more cheaper hardware, and that will specialize for certain tasks, right? One more that is not on any of the slides is maybe something we worked with is NSQL, which is a specialization for SQL generation, right? So all of these models are they're smaller. They are almost achieving commercial grade, but they are they're cheaper. So advantages, as I said, is they're economical, and they work very well with targeted tasks. You have to pay special attention on training them, and they might be biased, because in many cases the way you make them economical is you take out these custom tailored training sets and replace them with automated training sets. And if you use maybe ChatGPT to generate these automated training sets, then maybe you introduce bias into your process. But in any case, these small models are good at specialized tasks. And then to achieve something that maybe more affluent, bigger companies can do, like Microsoft, what do you do? How do you achieve that with these smaller models? How do you achieve ChatGPT 4.0 Turbo with these smaller models? Well, you have to find out, you have to somehow connect them together, right? And that leads into the next area that's, I think, currently very, it's a valid direction, and that's agents. And agents are basically entities or programs that will internalize different models and will work together to produce a good result, right? So you might have an agent system where you ask it a question about maybe plotting a graph in a Jupyter notebook, and to do that, it will have to understand what you want. But then as it starts doing the plotting, it might find out it's missing some libraries. So then several different agents might work together back and forth a couple of times before they produce and return back to you a nice plot that shows maybe, I don't know, Yahoo Finance data for a stock or whatever. So that's the direction of agents. And the next direction that is kind of being pursued in this economical side is, yeah, you can move ahead, Rudy. Microsoft AutoGen, I think, and LangChain are two examples of these agent platforms. Microsoft AutoGen, I think, is more geared towards code generation. All of this talk about Copilot. So those are the agents. In the next slide, we are moving into, you can move on to the next, context length. So that's about attention and context length. One of the eminent papers in LLMs that was developed 2016-17 is the paper from Google, "Attention is All You Need." And what they found out is that attention is one of the secret sources in these LLMs. Now the problem is, feeding an LLM with details before you can ask a question, that context length, it significantly impacts the memory consumption complexity of the model. So it basically grows quadratically with the context length. So one big effort that's being pursued is to somehow deal with the attention and to allow us larger context lengths at the same hardware level, right? So as you can see, these commercial offerings are now much bigger. Even the open source ones are using methods and strategies like rope and yarn and similar methods to try and do one extra step beyond what Mistral did in managing the attention, in allowing you to provide contexts that are maybe longer than the context that was used for training. Yeah. So, and finally, Rudy, so whether we should use these specialized context length expanded models, there are some indications that they might miss certain information that's in between, right? So they can easily miss information that's somewhere within your context, but maybe not at the beginning or at the end. So that's one of the disadvantages of them. And the final direction, payloads can be much larger, are larger, and it takes a long time, but of course it will be cheaper. The final direction in this second part is on fine-tuning, and in fine-tuning a method that's recently kind of very promising is Lorex and LoRa. And what they are talking about here is that we can use existing foundational models that maybe someone has spent a lot of money training, and then we can more efficiently, more economically train them. And especially this Lorex is almost like a system to manage. So we can have these cheap, very specialized models that are very good at certain things, but they're small, right? We need several of them to get results that are at the level of more expensive systems. And the LoRaX, you can now think about it in the same GPU, in the same system. You have 3-4 of these models, and they kind of switch dynamically this top several layers of the model to adjust to different tasks. That's what LoRaX is, and that's what LoRa is. It's basically how we proceed economically to fine-tune these models. Yeah, so if you move to the next step, Rudy, advantages, you will save, you will save on costs. I think maybe some problems that will arise is since you're using same or similar foundational model, and you're now trying to switch between different specialized sub-models, you might end up in problems that that they somehow interfere with each other, right? Because they're built from the same base. And of course, there is some multitasking overhead, but yeah, that's what you get. So anyways, that's the second part. Yeah, I wish I had more time to go into more detail what I prepared, but we've run out of time. I'm sorry. So back to Rudy.
We'll follow up webinars to dive into these in more detail. So we've kind of only scratched the surface. What we've tried to do here is we've gone into what OpenAI did, and then highlight some of the things that are available outside of OpenAI. So they announce a larger context window, but the reality of it is larger context windows have been already available, and there's tools to accomplish that. They announced the ability to incorporate build agent-like experiences, and there are tools out there to accomplish that as well with open source models. So I guess if you contrast it in that way, one thing that they have announced that we don't see an equivalent here is these GPTs and the ability to talk in a no-code kind of fashion, generate versions of a GPT. But all in all, if you compare all these sort of more recent developments and directions with the limitations, which sort of the biggest barriers in adopting large language models, which is the reliability, the ability to reason, ability to work with more specific and complicated data, that is an issue that still requires a very hands-on kind of implementation that is non-trivial, and there's active work in improving these models to change that. So all in all, large language models are providing value the way they are right now. You just have to be very careful and strategic about how and where you apply them. What are appropriate use cases, and with the data that you have, and and it's not just like which of my use cases would be a good fit. It would also be a question of what state is my data in. So if I know that I'll have bigger success if I organize knowledge in my organization in a particular way, then that needs to be a strategic decision, or something that the company needs to decide on. Is like, okay, I know large language models are moving fast, and I know improvements are coming, so this is not going away. And so even if right now they're not perfect, at least one thing you can do is prepare your internal data and knowledge so that you're more ready. And there's already certain patterns that are emerging here where you can see, okay, if I organize things. So the problem is, if you look at data, companies don't necessarily think about AI first. Data is this thing that sits behind your CRM, your ERP, and there's usually some kind of a logic layer in your applications that decides how to deal with that data. The question isn't like, how do I get knowledge out of my data for analytics? And that's kind of a switch in thinking that needs to happen here, where like companies need to actively put in an effort to devise an AI and data strategy, and then over time the models will become better, and there isn't really like you're not losing anything by doing that. So that would be sort of like the takeaway from this is you really need to be paying attention to your data strategy. You need to be careful about, if you're implementing large language models, where you apply them, because some of these applications maybe, it's not that they're not possible, they're possible, but they end up being a whole lot more effort, and you need to be aware of that. So
Yes.
I would like to thank
Just
you.
if I can maybe just add like a little bit of a side note, I'm sorry for just a second. Is we just finished training a model, a Mistral 7B fine-tuned model to generate SQL out of questions for Snowflake, and so just to give you